So, hello everyone. My name is Andrej Čižmárik and I would like to welcome you to this presentation where we will be talking about new features in data binding system. More specifically, we will be talking about the changes that have been implemented throughout versions .vvm 3.0 to the upcoming version .vvm 3.1. So I'm really happy to say that there have been some great progress and we implemented some really nice new features and changes. So yeah, there is a lot to go. So let's get straight into it. So the first feature that I would like to talk about is the introduction of lambda functions, or so-called anonymous functions. So just to be on the same page, in order to declare a lambda function, you have to provide input parameters list. Then you write this arrow-looking lambda declaration operator, after which you provide the body of lambda function, which can be an expression or a statement. And I'm sure that every .NET developer knows lambda functions, so it shouldn't be a big surprise that lambda functions in .NET do not have a specific type of their own, but instead they have to be assignable to a known delegate. And since .vvm 3.0 and partially in .vvm 3.1, we basically added support for compilation of lambda functions, and we support all the known delegates that are used throughout the base class library of .NET. And these delegates are system action, system func, and system predicate. So I'm sure everybody knows this. System action is a delegate that takes either 0 or multiple parameters and does not return a value. Func is really similar, but it does return a value. And then there is system predicate that takes exactly one argument and always returns a boolean. So before we jump straight into some examples and why this is such an important feature in .vvm binding system, I'd like to go over one more feature that was implemented in .vvm 3.1 and nicely extends support of lambda functions. So the feature that I'm talking about is actually type inference in lambda functions. And if you've seen previous presentations about .vvm 3.0, you've probably saw examples like this, where you can specify a lambda function, but previously it was necessary to explicitly specify the type of individual lambda parameters. So this is a valid syntax for .vvm 3.0, and in .vvm 3.1 this is actually no longer important or required to specify, as we've implemented a type inference system that in most cases is able to infer the lambda parameter types from the context they are specified in. So this is the new syntax that is supported by .vvm 3.1. So since .vvm 3.1, whenever you write lambda functions, it's quite possible that you don't need to specify lambda parameter types. Why I'm saying it like this? We actually right now support only a subset of capabilities that you may know from common C# compilers such as Roslyn, so that our type inference system works in most cases that you will probably require in .vvm bindings, but some cases might still not be supported. So let's have a simple look on how this works. So this is a really simplified overview on what we've implemented. So as we can see from the previous example, our type inference system knows that we have specified an expression that has a target of customers, which is probably a property in view model. Let's say we defined it as a list of customers, and then we know that user tried to call a where function, which of course is not implemented on list, but instead is an extension method in the LINQ namespace, where we know that this specific method has this kind of signature. And then our type system is able, for example, in this case, to unify those unknown types and therefore infer that the T should be a customer in this context. So this is a very simplified overview on how our type inference system works. And why I'm saying this is because some cases are not yet supported, for example, or mostly in named commands, which is, by the way, also a new feature that was introduced in DotVVM 3.0, where you specify a lambda. However, you specify it here without context. So right now we are not able to infer lambda parameter types for this case. And you may see an exception like this. However, if you supply additional type information, it will work really well. So right now, our type inference system should work in most cases, but there are some edge cases that are not yet supported, like usage of named commands. So there you have to specify these types explicitly. So why is this useful, and where can you use these features? So one of the great examples on where lambda functions can be used in DotVVM is actually client-side collections filtering. And what do I mean by this feature? So in DotVVM you can of course evaluate various expressions in value bindings, and there are some supported methods by DotVVM that gets translated directly into JavaScript code so that they can be evaluated purely on the client side, so that there is no communication with the server whatsoever for these bindings. And this is something that I feel like greatly improved in DotVVM 3.0 and 3.1 with introduction of lambda functions and various JavaScript translations that I'll be talking a lot throughout this presentation. So I have simple examples here. The first one you have already seen in previous slides. This is just a simple expression that tries to filter out all customers with an ID greater than 0. But right now you can specify, of course, more complex expressions, such as you can display customers that are sorted by a specific property, for example. So at this point, you might be asking yourselves, what can I actually use in these bindings? So what methods do we support? And the first batch of methods that I would like to talk about live in the system LINQ namespace. So whenever I'm talking about JavaScript translations, we always try to capture the behavior of these methods in .NET as closely as possible, and we try to replicate it in JavaScript. So this is our goal. But of course, since there are great differences between both of these environments, meaning the .NET and JavaScript, there might be slight differences in some obscure edge cases. However, in the general case, I'm pretty sure that the observable result of these individual operations will be the same as if it had been executed by .NET runtime. So what methods do we support from the LINQ namespace? So, for example, there are methods like all, any, concat, distinct, first or default, last or default, max, min, and even though I have written here some of these methods, there are actually a lot more of them, because in many cases we actually support multiple overloads of these methods. So later we will see the updated version of .vvm documentation, where we will go over a complete list of supported expressions and methods in the data binding system. So as I've been speaking, there are methods like order by descending, select, skip, take, and where. So we worked really hard to make these methods, or better said, their translations, to behave in the same way as in .NET, so that there are no, or better said, almost no observable differences when calling these. So, so much for the LINQ namespace. And right now I'd like to show you a simple demo of these operations. So I've prepared a sample for this. I'll first show you the sample, how it looks, and then we will go over the code. So this is a very simple application that have just a simple list of customers with some properties, and there are various operations that we may call on this list, so that we will see the result here in the filtered collection. So, for example, I can I may want to display this collection in a way that it's actually sorted by their that I want to sort the customers by their names, or I may want to sort by some category, or whether they're active, or by when they were actually registered at, and so on and so on. I can take the first 5, I can skip 5 customers, I can only filter those that are active or that are inactive. There is a lot that you can do with these expressions, and at this point I'd like to show you network tab, so that you can see that I didn't do any funny business in the background. This is actually really completed, executed purely on client side, so there is no communication with the server whatsoever, as I've been speaking earlier. So yeah, this is a really nice use case for lambda functions, and how you can utilize the new JavaScript translations of some LINQ methods to create data bindings that perform some operations on collections purely on client side. So yeah, that was this demo, and right now I'd like to go over some other features that we implemented in version 3.1 that will be closely related to this. So let's see what's new in the world of collections in .vvm. So up until .vvm 3.0, there were actually only 2 collection types that were truly supported in .vvm. Those were arrays and lists, and we supported something like basic usage of indexers and properties like count and length, so that you can retrieve the size of your collections. So let's see what's new in this space. So first of all, what's new with support for lists? And with lists, we added a lot of JavaScript translations that you can use, for example, from static commands, to actually modify your collections in view model, and similarly to previous JavaScript translations, all of this can be computed purely in the client's browser. So what methods do we support? We support methods like add range, clear, insert range, remove add, remove all, remove range, and reverse. So I believe like these methods are quite common with .NET developers when they manipulate with lists, and we also felt like we can add some utility function as extensions that you may find useful as we do. So we implemented 3 custom extensions, 2 of which are quite straightforward. These are remove first and remove last, both of which take an only argument, which is a predicate, so they remove either the first or last element that matches the predicate from the list. And the third method that we added is add or update, which is a method that takes 3 arguments, the first being an element that might be added in case there is no element that should be updated, and the other two arguments are actually 2 delegates, the first being matcher, which tries to find an element that should be updated in the collection, and if this delegate succeeds, it calls an updater that might update the element. And of course, in the case that the matcher fails, we just add the first argument to the list. So we feel like that this greatly improves what you can do in your applications with lists. So yeah, what's other news in collections? So actually, since .VVM 3.1, we added support for dictionaries. So since .VVM 3.1, you can actually use dictionaries in your view models, and to somehow match the capabilities which are supported with lists, we also added a couple of JavaScript translations for some methods. So first of all, we of course support the indexer, both the get and set operations. This is the thing that makes it possible whenever you're accessing list through those square brackets between which you can provide a key. So we support getting a value based on a existing key from the dictionary. We of course support modifying operations such as modifying a value based on an existing key, but of course adding a completely new key value pair in case the key is not yet present in the dictionary. Other than that, we also support 3 additional methods that should be also quite familiar. These are clear, contains key, and remove. So you might have noticed that we did not actually add support for a method like add on dictionary, and this is because the add method has a specific behavior where it throws an exception in case the key already exists. So in order for us to be more consistent throughout these environments, we encourage our users to use the indexer whenever they want to add a new key value pair into the dictionary. So yeah, so dictionaries and lists. So these have been an overview of modifying operations on collections in contrast to the operations that we saw previously, which were JavaScript translations of some methods from the system LINQ namespace. So right now I'd like to go over some more examples. So there are some more samples that I'd like to show you. First of all, I'd like to showcase that lists actually work, and you can modify them using static commands. There are various operations. I can add new elements. There is no, once again, communication with the server. I can remove a specific element. I can, for example, remove all even elements, and so on. I can reverse the collection. I can clear it and create a new one. So yeah, we basically support the basic operations that you would require if you were to modify your collections inside ViewModel. So if you would like to see how it looks like in code, we basically these operations are quite simple. So we use static commands and then leverage the fact that these methods are actually supported and can be translated directly into JavaScript. This is actually, as I've been saying, old syntax, so I didn't update this one, so you can use it like this, and similarly to those other cases where we use lambdas, and it will work just fine. So yeah, I think that this is pretty neat and easy to use. And also the other sample that I'd like to go over is a simple dictionary sample. You can see there is a render dictionary. I can add a new key with a value, let's say hello world. I might change, for example, an existing key to, let's say, a capital value, and I might delete some key value pair and clear whole dictionary, add a new key value pair. So you get the point. It's quite similar to the list demo. You can perform various operations on collections in DotVVM 3.1 that are actually fully supported on client side. So if I were to show this demo real quick, yeah, there are also static commands, and we are setting dictionary values in simple manner like this. So yeah, there should be no surprises, I think. And from the previous examples where I actually showcased the client-side filtering, I forgot to show you how those methods look like. I mean those data bindings, and they are quite simple as well. So you just call these supported functions. There is a lot of them, as I showed you earlier, and you can perform some filtering or even modify those collections as I showed in the last few slides. So yeah, these were the lists and dictionaries. So right now I think that we can proceed to other new features that were introduced in the previous versions of DotVVM. And the next feature that I'd like to talk about is an introduction of variables. So since DotVVM 3.0, you can actually use variables in data bindings. and there are some pretty neat use cases that you might use them for. So first let's get over how variables actually work in DotVVM. And in DotVVM, variables are basically of static single assignment form, which implies some rules on how you should declare them and use them. So the first important thing to note is that variables need to be declared before first use, but this shouldn't be too strange. But the second rule is more important, and that is that variables are only assignable once. And in DotVVM, you declare variables always with the var keyword, as can be seen in this simple code fragment. So you always first use the var keyword, then you provide an identifier for your variable, and in order for this to be a valid C# assignment, you always need to follow this with an assignment of an expression. So yeah, this is how you work with variables. And even though you never actually specify the concrete type of the variable, it's important to note that these variables are actually statically typed. So this means the DotVVM compiler always knows the type of every specific variable, and we are not using something like dynamic objects. And this should be all pretty apparent from the next slide, where I have a simple example that I would like to show you, where you can use variables. And a nice example is if you required setting multiple properties, for example, for a single button click. So we here on left side we can see a simple .html fragment. Here is a fragment from view model, and here is our custom static command service. So if we were to write a static command like this, in the first statement we actually declared a variable called result by calling the getNumber method on the static command service. This method is really simple. It just returns int, and it happens so that it's always a constant value of 42. So in this static command we actually capture the result of this method and then assign it to multiple properties, which are of course also integers. So as I've been saying on the previous slide, DotVVM compiler always knows specific type of the variable. So if these were not ints and there was no implicit conversion that could be applied there, you would actually get a type mismatch. So yeah, just keep that in mind, that variables in DotVVM bindings are statically typed. You use the var keyword to declare them, and these variables are only assignable once, and it's right when you declare them. So yeah, I think this is a pretty interesting feature for DotVVM data binding system, and I think that we can proceed to the next item on the list. So the next topic that I'd like to talk about is strings. So undeniably, strings are really important in many environments and runtimes. So it's quite apparent that developers work with strings a lot. So we felt like it would be a good idea to introduce some new features that would simplify the use of strings or allow for some new features to be used in DotVVM in connection with strings. So what did we actually do to improve this situation, or how or what new features were actually implemented. So the first thing that I'd like to mention is the support for string interpolation. So string interpolation is probably quite known for .NET, and I'm pretty sure that developers from other languages as well. It's basically just a syntax sugar for calling methods such as string format or string concat, depending on how complex the interpolated expressions are. So what's actually string interpolation? I think it would be better displayed on some examples. So in the bottom part you can see 3 examples of on the topic of string interpolation. So you always start interpolated strings with the $, exactly the same situation as in C#, and you can actually place in some specific places interpolated expressions that are encapsulated in curly brackets. These expressions will be evaluated to strings, and such string will be created for you at runtime. So this is a very simple example. If you were to have a name property inside your view model, this would be one way to create a greeting message for the user. And of course, we support more complex cases. For example, you might want to write a property such as datetime property and have it formatted in a specific way. So for this, we support the same feature as in C#, that you can actually specify your interpolated expression together with the colon, after which you write a specific formatting string, and this will yield the date time in this specific format. So if you are actually wondering what formats are supported, you might want to take a look at our documentation, and you would see that there are actually a lot of formats supported, as all of the formats that are commonly used in C#, except for some cases where some identifiers are not supported, but generally the support is really broad, and you can provide same format string that you are used to writing in other place of .VVM, but right now we created a new syntax that you can use them in. So you can use them in string interpolation as well. And string interpolation system also supports some more complex expressions, such as in the third example presented, but yeah, that's something that everybody would expect from this feature. So yeah, from .VVM 3.1 you can also use string interpolation. But this is not the only change that we did for strings in .VVM 3.1. We actually also added a lot of JavaScript translations that you can use in your value binding static commands and get and have them evaluated purely in client's browser. So what methods do we actually support on string? There are methods like contains, ends with, index of, null or empty, join, last index of, replace, split, starts with, to upper, to lower, and also their culture invariant versions. So yeah, I think that these are a lot new features that you can use in connections with strings. So yeah, we should now take a look at another feature on the list, and Right now I'll be talking about a couple of more features that I couldn't really place into other categories, or better said, I couldn't come up with a nice topic name for them, but they are not in any way less important than previous features. So yeah, let's get straight into it. So the first feature in this category that I'd like to go over is an introduction of extension methods to a .vvm data binding system. So yeah, you can use the import directive to specify what namespace you would like to .vvm to search for your custom extension methods. You may know this directive previously from .vvm. It was used to tell the compiler to where to look for certain symbols such as enums that you wanted to use in your data bindings. So right now what the import directive does is that it also searches these namespaces for extension methods. It actually works in a really similar way as compared to C#. So of course the .vvm binding compiler always prefers non-extension methods whenever you write a method invocation. So only once there was no viable non-extension method found, the .vvm compiler will try to match at least with an extension method, and this is the case where it will go over your import directives and will try to find the method that you wish to call. There is one small exception. We added the namespace system LINQ into default imports, so it's actually not necessary to write import system LINQ into your .html files. So this is basically added by default. So these methods that I shown previously in the client-side demo and so on, you can use them without the import directive. So please use the import directive for your own namespaces where you provide your own extension methods. And I feel like this is a great extension point so that you can create some code that might be shared across multiple pages or even multiple projects. So yeah, since .vvm 3.1 we support this nice feature with import directive, and you can also use extension methods. So I've already shown you the usage of extension methods in previous samples. It's just that right now I wanted to talk a little bit more about them and how you too can use this in your application for custom extension methods. So the next feature that I'd like to talk about is various improvements when resolving methods and looking for what methods a user actually wanted to call. So the first important feature that we implemented is that we now support a variable number of arguments for methods. This is commonly known in C# as the methods with the params keyword, which allows for this nice little syntax that you can seamlessly write variable number of arguments and it will be passed to the method as an array. It's already in use in .vvm by some by some JavaScript translations. And the other important improvement is the support for generic methods. So as I've been saying, .vvm improved its support for resolving and matching methods so that from version .vvm 3.1 there is the possibility to use even more complex generic methods than it was possible before. So yeah, these are, I feel, all really nice improvements and changes that we did. And yeah, I wouldn't like to forget about math methods. So as I've been saying, we added a lot of JavaScript translations, and math methods weren't an exception, so we added a lot of translations here as well. You can see on the slide there are various mathematic functions that we now support, some of which are more, some of which are a little bit less common, but you may use them in your data bindings, and there are quite nice and simple operations that can be evaluated on the client side as well. So at this point, this was the last batch of JavaScript translations that I wanted to show you, and right now I'd like to show you what I wanted to show you in our documentation. So if you come and have a look at our documentation for .vvm 3.0 and up, there is a section under concepts called data binding, and under the data binding there is this nice page called supported expressions, and here you can actually see all the available syntax that you can use inside data bindings. There is a lot of it to go over, and there are also available .NET methods that are supported in value bindings that were previously supported, I mean up to version 3.0. So these methods are of course still supported, but in .vvm 3.1 we added a lot of them. So here you can find the whole list of supported methods and their overloads, as I've been speaking earlier about. So starting with the LINQ namespace, there is a lot of them and various overloads. Then there are the list methods that you've seen in the example where we try to modify a list inside static commands. Then there is dictionary methods, a lot of string methods and their overloads, and lastly the math methods that I just show you on the last slide. So right now I'd like to summarize the changes in these versions. So in .vvm 3.0 we introduced lambda functions, and this feature was further improved in version 3.1 by adding type inference support. We added a lot of method translations for various LINQ operations that you can use together with collections to perform various operations in value bindings. We also added a lot of method translations for common list operations, and we also added a couple operations of our own that we really like to use in our applications. This was also done in the version 3.1, and in version 3.1 we actually added support for dictionaries and also some other method translations that you can use together with dictionaries. Once again, for example, in static commands to perform some modifications on these collections. And then in version 3.0 we added variables so that you can write some more complex commands in your applications that actually leverage the availability of variables. Then in version 3.1 we added string interpolation and various string methods so that you can write even more interesting data bindings in connection with strings. We also added support for the params keyword that you may use in your methods that might be called from data bindings. We did various generic improvements also in version 3.1. We added support for extension methods, and from the version 3.1 you can use the import directive as I've been talking earlier about, and of course math method translations in 3.1. So I hope that I did not forget any important feature in connection with data bindings. I hope that you really like this presentation and that you realized how many new features there were implemented in the version 3.1 and that you will not forget to upgrade your applications to this version once it comes out. There is also a repository available for you that you can visit that has all the examples that I showed previously, and also these slides, so you can play with these new features. This repository is actually based on the latest preview of DotVVM 3.1, which is really close to what will be actually the final release that should be hopefully out in a few days. So once again, I'd like to thank you for your attention, and if there are no questions, then I'd like to thank you once again for attending this presentation, and stay tuned as there is more to come today. So once again, thank you and bye.